Hi friends, welcome back to C Level Physics. My name is Srinivas, known to be BS Rao. In this lecture, I would like to explain equations of motion. By the name itself, these are some mathematical expressions connecting initial velocity, final velocity, displacement or distance, acceleration, time, etc. Okay, which describe the motion of given particle. That is the reason why the name has given equations of motion. Okay, we are going to derive all these expressions making use of calculus method. Okay, before that we need to know some points. Suppose when a particle is under motion, the time or the instant when our observation starts is said to be initial instant. Am I right? So when time t equals 0, whatever the velocity noticed is said to be initial velocity. Okay, let b small u. When our observation ends, say at time t equal t, the velocity noticed is said to be final velocity. Let be v. So u means initial velocity, v means final velocity. And moreover, in that time interval 0 to t, particle may cover some displacement. Okay. Now that can be denoted by alphabet small s, which is equal to displacement. Sometimes equal to distance also. In cases in which direction is not reversed. Okay. Right. Now coming to acceleration. Whatever the acceleration possessed by that particle is denoted by letter small a. Here acceleration is constant. Whatever the equations we are going to discuss now, those are valid for accelerated motion only. Accelerated motion. But uniformly accelerated motion. These expressions are valid for uniformly accelerated motion. So acceleration is constant. Acceleration constant in the sense path must be straight line basically. Right? So a particle moves along a straight line without reversing, without retracing. In that case, displacement becomes equal to distance also. That is the reason why I am saying that displacement sometimes equal to distance also, provided direction is not reversed or altered. Okay. Now, time involved, let it be small t. So these are the parameters, okay, among which we are going to derive some mathematical expressions which describe the motion of given particle. Am I right? Suppose I am taking one particle which is under motion like that. See, this is what path followed by the particle, right? At time t equal to 0, our observation starts somewhere here. At time t equal to 0. Now, what is the velocity of particle at time t equal to 0? Let it be small u. Let it be small u. So, u be the initial velocity. Suppose particle is under motion covering some displacement. Okay. When our observation ends somewhere here. Now, what is the instant here? Time equal to t. T equal to means time equal to t. Time equal to t. Am I right? Alright. Now, what is the final velocity? Notice at that instant, let it be small v. Let it be small v. Am I right? So, u means initial velocity, v means final velocity. Now, what is the displacement covered at time t equal to 0 means that is 0. So, s equal to 0 here. Now, when our observation ends, what is the displacement covered by the particle? Let it be s. So, displacement s equal to s. S equal to s. Now, here see, particle undergoes some change in velocity from u to v and covering a displacement s, otherwise in a time interval 0 to t, right? Definitely particle undergoes some change in velocity, means it is accelerated. What kind of acceleration? Uniform acceleration. See, path is straight line, moreover it undergoes equal changes in velocity in equal intervals of time, however small these time intervals may be. Okay, that is uniform acceleration. What is that acceleration? Let it be a. Let it be a. Otherwise a bar. Here u bar. Here v bar, like that. Am I right? Here s bar. Displacement s bar. These are vector quantities. Initial velocity, final velocity, acceleration, displacement. These are vector quantities. Am I right? Now I am going to derive first expression, that is v equal to u plus k2. Number one. That is v equal to u plus a. Right? So to derive that expression, I am taking a bar equal to dv bar by dt. Means instantaneous acceleration, a bar equal to rate of change of velocity. Implies that dv bar equal to u bar into, sorry, a bar into dt. A bar into dt. dv bar equal to a bar into dt. Means within every dt, what is the change in velocity? dv. In every dt, in every instant, that is in every dt, particle undergoes a change in velocity dv bar. A change in velocity dv bar. Now in a time interval from 0 to t, there may be a large change in velocity, that is delta v bar, from u bar to v bar. How to get that large change in velocity in total time interval? Means by summing all these small increase in velocities or small decrease in velocities, whatever it is. So if I add all these dv's in every dt, then I can get total change in velocity in that large time interval. So that can be done by mathematical method, that is integration. So integral dv bar equal to integral a bar is constant, that is kept outside, a bar into dt. A bar into dt. What is the time interval here? At time t equal to 0, what is the velocity u bar? So at time t equal to 0, here t equal to 0, what is the velocity? U bar. At time t, what is the velocity? V bar. So these are the limits, u bar to v bar, here 0 to t. Now integral dv means, say, if I add all these dv's, you can have large change in velocity, that is v minus u, otherwise v. So integral dv means v or v bar, limits u bar to v bar, that is a bar into integral dt means t, that is t, limits 0 to t. So here take upper limit in case of v bar, that is v bar minus, now take lower limit, that is u bar. Instead of v bar, take u bar. So v bar minus u bar equal to a bar into upper limit t, lower limit 0, that is t minus 0. So t minus 0, that is t minus 0 means t, v bar minus u bar equal to a bar, that is v bar equal to u bar plus a bar t. That is, this is what in vector notation. In case of straight line motion, there is no significance for arrow mark. So I am taking without arrow marks, that is v equal to u plus at. V equal to u plus at. Am I right? This is what first expression, first equation of motion, connecting initial velocity, final velocity, acceleration and time. Okay, right? Coming to second expression, number 2. Second expression, s equal to ut plus half h square. S equal to ut plus half h square. So second expression, s equal to ut plus half h square. This is the expression connecting displacement, initial velocity, acceleration and time. Right? So to derive this expression by calculus method, first of all, you have to consider v bar. V bar equal to ds bar by dt. V bar, instantaneous velocity. At any instant, velocity like dv, that is ds bar by dt. Rate of change of displacement is instantaneous velocity. Here see, velocity changes at every instant from u bar to v bar in a time interval t. So I am taking rate of change of displacement as velocity, right? Now implies on cross multiplication, what happens? ds bar equal to v bar into t. ds bar equal to v bar into dt. V bar into dt. What is the significance of this expression? In every dt, what is the displacement here? ds. In every dt, within dt displacement ds, next to dt displacement ds, in next to dt also displacement ds, like that, right? So on integration, integral d is saying that total displacement in time interval t. So how to get that larger displacement means by integration. That is integral ds bar equal to integral v bar dt. V bar dt, right? Now limits. At time t equal to 0, what is the displacement 0? At time t equal to 0, what is the displacement 0? At time t equal to t, what is the displacement s bar? At time t equal to t, what is the displacement s bar? Now integral ds means total displacement. Integral ds in the sense summation of all ds values. Addition of all ds means gives total displacement from 0 to s. That is s bar. Limits 0 to s bar. That equal 0 to s bar. That equal to v bar. V bar means what? Here see. This is what first expression as an example number 1. V bar equal u bar plus at. So eliminate v bar by writing u bar plus at. So 0 to t u bar plus a bar into t. Since from 1. Since from first expression v bar equal to u bar plus a bar t. Now s bar upper limit minus lower limit, that is s bar minus 0 bar equal to u bar is constant, initial velocity constant, so u bar is constant, u bar into integral dt means t, u bar into integral dt means t, limits 0 to t plus a bar constant, integral t dt means t, that is s bar minus 0 means s bar equal to u bar into upper limit t, lower limit 0, that is t minus 0 plus a bar by 2 is outside as it is constant. We left with t square upper limit t, so t square minus lower limit 0, t square minus 0. So what is the expression we left? Means s bar equal to u bar t plus half a bar t square. S bar equal to u bar t plus half a bar t square. Right? Now in scalar notation, s equal to ut plus half a t square. S equal to ut plus half a t square. So see, this is the expression connecting initial velocity, acceleration, time and displacement. In general, s means displacement. Sometimes becomes equal to distance also, provided the direction of motion not changed. Okay. So s equal to ut plus half a square. Coming to third relation. That is third relation. What is that? Number 3. V square minus u square equal to as. V square minus u square equal to as. Right? V square minus u square to as. This is a relation connecting initial velocity, final velocity, acceleration and displacement. Right? So to derive that expression, I am taking acceleration a equal, otherwise acceleration equal to v into dv by ds. V into dv by ds. We know that acceleration equal dv by dt, otherwise d square s by dt square, otherwise v into dv by ds. V into dv by ds means chain rule. This is what? Chain rule. So what is the significance of this relation? Within every ds, what is the change in velocity? dv. So in every ds, I am covering every ds, the change in velocity would be dv. That is the significance of that relation. Implies that that is on cross multiplication v dv, v into dv equal to v into dv equal to a into ds. A into ds. See, in every ds, what is the change in velocity? dv. To have total change in velocity and covering total displacement, how can we get that relation? Means by taking integration. That is integral on integration. On taking integration v dv equal to a into integral ds. A is kept outside. Why? Because that is constant. Integral v dv. What are the limits here? When s equal to 0, what is the velocity? U. So when s equal to 0, what is the velocity? U. Initial velocity. When s becomes s, what is the velocity? V. So when displacement becomes s, what is the velocity? V. Right? Okay. Now integral v dv means v square by 2. How can you say that? We know that integral x power n dx equal to x power n plus 1 by n plus 1. That is the relation. Integral x power n dx equal to x power n plus 1 by n plus 1. Here integral v dv. What is the power of v? V power 1. So v power 1 plus 1 by 1 plus 1. That is v square by 2. V square by 2. V square by 2. Limits u to v. That equal a is constant. That is kept outside. Integral ds means s. Limits 0 to s. That is 1 by d is constant. What is the factor here? V square. Take upper limit minus take lower limit. That is v square minus u square. V square minus u square. That equal a into upper limit minus lower limit. So we left with v square minus u square equal to 2 into as. 2 into as. Right? This is what relation connecting initial velocity, final velocity, acceleration and displacement. In vector notation, how can you express? That is v square means v bar dot v bar. So v bar dot v bar minus u square means u bar dot u bar. U bar dot u bar. That is 2 into a s means a bar dot s bar. A bar dot s bar. Right. So v bar dot v bar minus v bar dot u bar, that is equal to into a means a bar, s means s bar. Right. Okay friends, this is about equations of motion. Right. In next lecture we will discuss few more relations, okay, which can be derived from equations of motion. Okay, thank you.